Okay, and now we're going to continue our day with the GeoAI Leap for Geospatial Intelligence panel. And we are very fortunate to have Dr. Nadine Alameh, a preeminent expert in GeoAI, to lead the discussion. Nadine?
Thank you. Can I use the podium?
You can use whatever you'd like.
All right. And the clicker is here. Where's the clicker? Over there. I'm walking on a stage. So cool. All right. Should I go back there or stay here? My choice. I love this. All right. So good morning, everybody. I'm Nadine Alameh, and I'm very excited to be here today with you. And we're all going to talk about this leap, this generative AI leap for geospatial intelligence. I will start here. Exactly a year ago. I was here with Boodoo. I know Boodoo is here, and Keith, and we had a session on GeoAI, an emerging opportunity. And in my piece of it, I talked about let's together build this ChatGPT of Earth and what it actually entails. And we talked about that we have to deal with, how do we go from imagery to words and large language models? What's the infrastructure like? What's the cost of building and training? What's the open science implications, the trust? What are the metrics, the benchmarks? We talked about all of this a year ago, right? Under emerging opportunity. And then here we are today, and now that I'm looking, by the way, Chris Tucker, I did get these pictures from the videos online from last year. So yes, you can actually rewatch the whole symposium from last year. And apparently I stuck to the color pink. So here we go. So it's been a year from November 24 to November 2025. And so much has happened in this topic of generative AI. Like, how do we use AI to generate new information, new processes, new data, new dashboards, new maps, new decisions? And I'm going to run through this with you. And your head hopefully will spin, just like it spun with the quantum guy earlier, the presentation. So very, very quickly. November 2024, right after we met here, NASA announced the Earth AI Copilot with Microsoft, where you could ask what's the impact on this island because of this hurricane. December 2024, IBM and NASA, who have been collaborating for years before, issued or announced Prithvi EO 2.0. They trained it on Landsat and Sentinel. That was huge, Earth observation. In March, many things happened. March 2025, Niantic, we heard from Niantic yesterday. They spun Niantic Spatial. They are embedding spatial reasoning inside large language models. What else happened in March 2025? Planet announced that it's partnering with Anthropic Claude. And what are they doing with it? Pattern recognition, anomaly detection at a global scale. Same month, Earth Genome. I know there are folks here from Earth Genome. It's a nonprofit. We talked about it last year. They have the Earth Index for environmental monitoring. They announced that the Earth is searchable on Earth Index. This is March 2025. April, IBM and now ESA. So on the European side, European collaboration, they announced TerraMind. And in this case, they were using, 9 modalities where you can actually fill in the blanks because you have data in other modalities when you're doing your training. Big announcement. Also in April, GeoGPT launched. I just came from China and met the team. And this is same thing, foundation models for the geoscience community. Also in April. June 2025, the researchers at the University of Cambridge announced Tessera. So Tessera in this case is like EO time series, that's the T, and pixel-oriented foundation models, that's June 2025. July, now we're into the summer. I think this, I don't know if your LinkedIn buzzed the way my LinkedIn buzzed on this day in July when Google announced the Alpha Earth foundations. This was huge news, and same thing. This is pixel-level embeddings, Sentinel, and Landsat, and they announced geospatial reasoning, so it allows the researchers to use their data models and their data with the Google foundation models. Again, imagine everybody throwing all of this at you at once. Also in July, our friends at Clay, we talked about Clay last year. So they're building this large AI foundation model of the Earth, and they spun off an actual for-profit entity in this case because they want to build the ChatGPT for Earth. Summertime, August, Meta announced Dino V3. This is self-trained computer vision that has been extended by amazing researchers worldwide to apply for remotely sensed data. That's August 2025. So Meta now is joining, and we heard also yesterday about the Segment Anything version 3. It literally came up on the way here. October 2025, Maxar rebrands, and they unveiled the AI platform. What is it? TensorGlobe, so AI-powered spatial intelligence platform. What else happened in October? Esri, Science with AWS for advancing generative AI in ArcGIS. More, November 25, I think, was it last week or 2 weeks before? This is the Allen Institute of AI. They announced Olmo Earth, not OmniEarth, Olmo Earth, which is an open AI platform for Earth monitoring. Now you tell me, is this a lot or what? This is like this gold rush by everybody to do this in this generative AI for geospatial field. All in one year. So it's amazing. It's an amazing time. I love it because we're all in this little circle. We're all here. There's this rush because we've got the geospatial and the Earth observation and the data. We've got the compute and the infrastructure and the cloud and the quantum. And now we've got this artificial intelligence. And here we are beginning this unbelievable acceleration of innovation in our field, right? In the field that we like, the geospatial field. So we can talk a lot about what is generative AI for geospatial and what are people doing in terms of innovation, or we can see. What do you want? Do you want to see? Yay! So I'm very, very excited because we get to see 4 amazing entrepreneurs. So I love it, right? You have now this ecosystem for researchers to do anything they want and for entrepreneurs to build these amazing companies based on their innovations. So we've got 4 entrepreneurs up on stage that are betting in a way, right? They are using all of this to create the next generation of solutions. So I'm going to introduce them one by one. They'll come up here to show you, right? And then I want you to ask them all the questions about, why they're doing this, how they're doing this, how is this different, where is this going, how can I use it? Deal? Yay! It's the voice in my head. So I'm going to start with Dr. Sean Gorman. He's definitely a serial entrepreneur. He's the co-founder and CEO of Zephyr. And he had several startups before. You can read his bio. One was acquired by Maxar, one was acquired by Esri. He's also, he worked at Snap. He's also a research professor where he did his PhD at GMU. So there's nobody better to actually show you what the future can hold with this combination of generative AI and spatial/geospatial. Sean?
Thank you, Nadine. Appreciate it. Cool. Thank y'all. Just wanted to talk really quickly about some of the work the team back home's been doing for creating AI-powered navigation and local search. So we're thinking pragmatically about how people move through the world and interact with AI. Because as you know, you can talk to ChatGPT or Claude, and it's really good at telling you things, but it's not very good at understanding where you are and how you're interacting with the world. And so that's the problem we wanted to solve. These voice interfaces are really powerful, but when I ask that voice interface, where am I? What am I looking at? What's nearby? Is the Starbucks to my left or my right? How do I get to the Alfred J. Lerner Center? The large language models and even some of the vision models are challenged in a lot of these spaces. And so we took, we like these kind of what we call barely solvable problems. And as if you remember from Brian's wonderful talk yesterday, the challenges of using just the IMU and the GNSS to figure where you are and what you're looking at isn't an easy problem. So we've been working hard on providing kind of a virtualized positioning engine to do that, with the concept of then once that device knows where you are and what you're looking at, can you have a conversation with it that's geospatially enabled? And one of the things we found that's kind of critical for this is, one, taking the existing data that we have, making sure that it's accurate in the right place in the world. If you're looking at things, the things need to be where they are, mapped to reality. And then also that data needs to be structured in a way that an AI agent can use it and have a conversation around it. It needs to understand those basics of orientation, left, right, forward, back, across the street, up, down, et cetera. So that's the bit that we've been looking at. So the first piece that we've kind of tackled is, how do we go and generate data for this? We spend a lot of time orthorectifying imagery from the air, but we can also orthorectify or georectify imagery from the ground. So as I take pictures of things with my phone, can I turn that into geographic data and extract information from it? And it ends up that AI is quite good for this as well. So we did this experiment on the Pearl Street Mall in Boulder last week, and we had a team of 3 go through and map about 200 places in under an hour. And all they were doing was going by and taking a picture and leaving an audio note saying, hey, I've taken 2 pictures of the entrance, the name of this place is El Centro, or sometimes just nothing and let the AI categorize the photos and build out a schema for what it's seeing. So this is an example going through it. Here on the right, you can see that schema that got built out from it, from the images. It picked up things like events, the menu, the operating hours, again, all from photos. So here we can see the video of one of the people collecting.
This place is called Centro Mexican Kitchen. It's a Mexican restaurant. Centro has a happy hour from 2 to 5 p.m. and brunch on Saturday and Sunday.
So from that, it was going through, and just from a handful of photos, was able to create this whole rich profile for the events, when they were happening, menu items, prices, et cetera. And then we've also played around with doing the same concept for augmenting existing places, like an OpenStreetMap or
Do you have any tips or info for finding Double Happy Chinese Restaurant?
This is the entrance.
Got it. Logging. This is the entrance for navigation_tips. Do you have any reviews for Double Happy Chinese Restaurant?
It's wonderful for takeout.
Got it. Logging. It's wonderful for takeout. For reviews. Are there any menus for Double Happy Chinese Restaurant?
So you can see we can either have a free-form experience where you're just taking pictures and the AI is figuring it out, or if you want to direct somebody to collect specific things about places of interest that already exist, the agent can help walk you through and collect those places and categorize it. And then from that, you can see we're extracting from that image the opening hours, that it's an entrance, the visual description, structuring those hours into a tabular structure, and then putting those all into embeddings so that the AI agent can go through that soup and answer intelligent questions when you want to know things about it. So we'll show you just a quick example. So now that we've taken this data, and this was 5 minutes after the data was collected, and now we can ask those agents questions and they can give us interesting answers on it.
Hey Zephyr, are there any good women's clothing sales going on nearby?
There are a few women's clothing stores nearby that may have sales. Free People, a women's clothing store, is 10 meters to your right and slightly in front of you. Earthbound Trading Company, another clothing store, is 20 meters to your left and slightly in front of you, and is currently having a buy one get one 50% off sale. You can also check out Athleta, a women's clothing store, which is 90 meters to your right.
Hey Zephyr.
Oops, going to play them all at once. But hopefully you get the idea, right? That as you're collecting this data and structuring in a way that the AI agent can go through and make intelligent sense of it, it can understand not only spatially where you are, where the object is that you're looking for, query about things that are relevant, but also adding in events, right? There's a happy hour going on right now. There's trivia night at this place. And those things are all temporally driven, right? There's even stuff like menus. There's another video, unfortunately it was playing over it, but where can I get patatas bravas right now and how much does it cost between these two places that are both within 50 meters of me? So these are all like exciting directions, right, that are coming together in exciting ways. And the fun thing is building these kind of detection and extraction models are all prompt driven, right? So we did these kind of common POI things, but what if you wanted to do a damage assessment, or you wanted to extract trail markers with directions, or you wanted to read a utility meter? Again, these things are very easy in a WYSIWYG kind of way to dial in the agent to do really fun things and create geospatial in novel ways. But thanks, we'll see lots of other cool stuff coming up here.
Thank you so much. Isn't that amazing? It's like we are the connectors of all information because of the time and space. So Mr. Jesse Kallman is the founder and CEO of Dante. I've been using your demo for at least 4 years in my presentations in terms of like how we can be searching for things using natural language. But Jesse has a career in small business and government and large business. I see Booz Allen, I see Airbus, and now your adventure with Dante. So you want to share more about it?
All right, thank you. And thanks for having me. So Jesse Kallman, founder and CEO of Dante. Just a really quick background on who we are, what we do, why we're doing it. So the purpose of building this company was after years of working with drone technology, satellite imaging, and when I'm at a satellite company, the answer to every problem out there is a satellite image. When I'm a drone organization, the answer to every problem is a drone video. And kind of what we've learned was that it's all of it, right? And it matters contextually what you're trying to do. And based on the question and based on what the user's intent is, sometimes the answer lives in a drone video, lives in a satellite image. Sometimes you can get the answer from a tweet that you've geolocated and understand that it's relevant for the topic at hand. And so what we're building is really that knowledge layer that understands, based on what the user's trying to accomplish, what are the right types of technologies and data to use contextually to help you answer the question. And so the company, we've really focused initially on the US government market, and so now we're beyond many hundreds of thousands. I'm not sure if we've crossed 1 million searches yet across all of the US government, DoD, intelligence community, and civil. But think organizations like US Space Force, who's trying to support global wildfires, but they don't have SIGINT, GeoINT experts in their team. They're just trying to help the Chilean government better understand the wildfire's proximity to local schools and infrastructure. Or, there was an example earlier of maritime domain awareness, right? And so there's a lot of experts that know how to do that, but there's a lot more people that need the output of that don't understand the tradecraft behind how to do that. And so I put this slide in here because there was there was a discussion earlier about graphs and LLMs, and in our experience, you can't just throw a bunch of spatial information at a language model or Alpha Earth or something like that. It depends contextually what you're trying to do, and then how do you sequence the right workflows for the user? How do you build software around it so that the user can ask questions, share with colleagues, monitor and alert, and do other things? So since this is a more technical crowd, the system is actually an ensemble of technologies, right? An LLM can't accomplish this, a graph can't accomplish it on its own, and even certain classical machine learning techniques as far as like how do you rank information and how does the system learn over time. And then behind the scenes, a lot of the stuff that we've been doing is how do you encode specific workflows? So again, to that maritime example, and I'll show a couple quick examples here, but to that maritime example, maybe you have an initial search, but then there's several sequences and models you need to use in a certain sequence to actually get to the end output. Some of it may be a pattern of life analysis. Some of it might be intra-image search and understanding, what we've seen in some of like the larger spatial models for Earth data. And then all of it comes together contextually to help answer some of those questions. So I'll show a few quick examples here. So this is one of the government instances of the system. There's many different types. You can consider Dante like a set of nodes. So each node is connected to government data, commercial, open source information. If I'm a government analyst and I'm just told to look at Gaza broadly, say for example, you can spatially understand a certain location. And what this system will now do is it's looking at every news organization, social media outlet, POI data, maritime. You didn't really give it any semantic context, and it'll return to you quickly everything that news and social is talking about, every ship in and around the area, what local critical infrastructure is there, and then you can ask follow-on questions, right? It's detecting fires that's likely from strikes in the area, so it understands all of these things contextually, and then you can ask follow-on questions to drill into the map. Any images that are captured that are there. So another sort of more governmental example, right? So if you ask a more specific question, maybe I'm researching, drug smuggling in parts of Venezuela. In this case, now you're seeing much more contextually relevant information. It's finding the ports of interest. It's pulling signals and electro-optical information. It's pulling the actual port data. It's finding, actual images of those ships visually because it understands that. And I think the key piece here is that the user doesn't need to know anything about signals intelligence or maritime domain awareness. They just ask the question and the system will contextualize it for them. And even a more complex question here, something around looking at ships in the port of Shanghai and where they went. Again, this is something that traverses many different types of skill sets. And in this case, it's understanding like where those ships are going, generating the tables for you. So these are the kinds of things that typically traverse many different type of analysts and their backgrounds. And given that there's a lot of research going on here, we're also even doing work with organizations like CAL FIRE, where the system, if you're a firefighter that has no knowledge of the geospatial industry, can just ask what critical infrastructure or schools or police stations are the fires closest to. The system understands how to work those workflows. It can pull NASA firms information, the local winds, auto-calculate fire extents, pull local POI, and in 10 seconds give them the key things that they need to know without having to reach back to that expert. Thanks.
Thank you. Thanks. Again, in terms of just being inspired about what we can do today, when people talk about multimodal, this is multimodal. It's news, it's social media, it's structured data, it's unstructured data, it's geospatial data, it's not geospatial data if that exists. So our next entrepreneur, Dr. Matt Reisman, and Matt is the co-founder and CTO of Bedrock Research. He's early in this journey with a PhD physics in Washington University, but one of my favorite bits in your bio is that when you were at Lockheed Martin, you were behind the first operationally deployed deep learning computer vision algorithm for the intelligence community. So maybe you can tell us a little bit about Bedrock Research and what you guys are doing with foundation models.
Sure can. Yeah, thanks, Nadine. Hi, everybody. So Bedrock Research, as Nadine said, a fairly new small business that was basically created to solve the problem of the satellite data deluge that we're all facing right now. So over the last 20 or so years, the presence of satellites and the breadth and volume of imagery they're collecting has really ramped up exponentially. And that sounds great on paper, right? We're not gonna miss anything. We're gonna see everything always, no matter what. We're always gonna have imagery of stuff. But it has really suffocated the end users, the analysts, the companies, whoever needs to actually extract and exploit the imagery. It makes it really hard when there's a lot to sift through. And it's not just a volume problem, it's also a kind of diversity problem. There's 5 examples here of different kinds of imagery that all of our satellites are capable of collecting today, and they're extremely different. They look really different to a human, the resolutions are different, the perspectives are different, the number of wavelengths they have are different. Sometimes they don't even look what we're used to seeing as humans, like radar-based imagery that have all sorts of different components and features to them. And not just the breadth of data, but the applications to which we use these imagery are very diverse too. What someone would need in defense is very different than what someone would need in environmental monitoring. And somebody said yesterday, I really like the quote of, we're not really facing a data problem anymore, we're facing a data science problem. And in remote sensing and satellite image processing, there's a bunch of algorithms over the last 10 years that have come around, a lot of deep learning and AI stuff, that are really good at taking those images and applying them to different areas of interest for different things. And the problem, though, is those kind of required specialized training and data labeling and stuff like that. If you needed to do object detection for maritime logistics, you might grab a bunch of visible imagery, label it, train an object detector, and deploy it. But if you needed to do detection of things for construction, you'd have to train a brand new model for that. If you instead wanted to do classification for maritime, you might have to have a completely different model for that. And this gets out of hand really quickly, where for every problem, every need, you have to grab a new batch of data, you have to train a new model with new tasks and new goals, and you end up with just this suffocating volume of algorithms that's not sustainable. It's really expensive and time-consuming to label all this data and train all these models over time. And end up with things that really generalize to the diversity of applications we're facing. So the way we solve this problem at Bedrock, there's kind of two key ingredients to the solution here that both surround this concept of geospatial foundation models. The first is maps, what we're all kind of here in the room together because we're excited about. Maps in geography. I think it was Brian from Niantic in his talk yesterday said, maps are facts. I really like that as sort of, it's this absolute truth that is, regardless of sensor perspective resolution, the underlying map is the reality of that. So we can use those maps with some pretty sophisticated image and geo-registration algorithms to say, okay, I know exactly with different images, it's the same building in two different images, even though they look really, really different from one another. And that lets us have, instead of inputs from all these different sensors depending on the need, we're truly sensor agnostic. We can take an imagery from any sensor, any perspective, any resolution, and standardize that way. And the other key ingredient here is generative AI. So when you hear things like foundation models, you probably think LLMs first. A lot of times those two terms are used interchangeably. ChatGPT is a foundation model. But what we're talking about here is not a language model. We're taking kind of the tech and the great innovations that have occurred in the language processing domain and applying it to image processing. And a quick example of what that looks like is on the right, where the reason these are so powerful is because you can learn lots and lots of information without having to manually annotate data. So the language models are trained by grabbing all the great text from the open internet, masking out words, and asking it to kind of stitch together what should have been in those blanks. We can do the same thing in the pixel space in the satellite image domain. And through that process, you learn this incredibly rich feature space of any and all things that are in all these different images. And what that lets us do is then take this singular geospatial foundation model and apply it really quickly to these different application areas with a much less overwhelming kind of spread of algorithms that take many months and many hundreds of thousands of dollars to train each time. We can do it a lot faster and cheaper. And beyond just the data types and the application areas, what we want to do is kind of adapt quickly to this coverage area of how frequently do you need to look at something and measure something there, and how big of an area do you need to look over. We want to make sure we can go anywhere in this space very quickly and very efficiently. So a few examples of what this might look like. Daily site-specific monitoring, a very common one in defense, where something has happened, right? This is the nuclear facility in Iran that was attacked over the summer, and we can take a pair of images. If we've been monitoring it every day, we can say, oh, something happened there, let's zoom in and do this kind of day-to-day change detection. And with this foundation model, we can really quickly extract where has the most significant change and kind of occurred and what does it look like without having to retrain on these kinds of sites. We can zoom out a little further and do something like cross-sensor reacquisition. So we can do this, remember, we're sensor agnostic, so we can look over maybe days or weeks, and if we want to know how these container ships in the port of Hong Kong are evolving and coming and going, when one leaves, how long does it take to come back? We can do that and compare these things across different sensors to really efficiently monitor activity in an economic sense. And we can also do broad area change detection. So think much slower change, things like construction or environmental consequences and things like that. We can take data, say, over the entire state of Colorado or even bigger regions and use the same exact foundation model that does the daily stuff over kind of longer time scales and larger areas to say, where has the most significant change occurred, zoom in and see what kind of change has happened and use that for whatever downstream application might be of interest. So what we're doing at Bedrock, to summarize, is really just trying to take and harness the strength of these foundation models to do as generalizable of remote sensing data processing as possible.
Thank you so much. Thank you. Thank you, Matt. I mean, once again, this is just to whet your appetites, right, about the possibilities of this combination of AI and generative and the geospatial. But also, to me, what gets me excited is that if you are developing applications for a customer, there are now new ways to build the solutions that are really different because we've got a whole new tool set at our disposal these days. So speaking of building solutions, Mr. Robert Carroll has been building solutions for the industry for over 35 years. And I see leadership roles at Vexel Data, Nearmap, and EagleView. And you decided now to found a new company, Terra Analytics. And you're going to tell us a little bit about it. But before I go there, I also see in your bio that you're writing a book on pixels to insights, seeing the unseen. So I'd like to see the unseen.
I'll get you a copy.
So thank you.
Well, thank you very much. It's a pleasure to have a chance to talk here today. I'm going to talk a bit more of a pragmatic application of this type of technology and how it's potentially being used in a more immediate, localized type of application than what we've seen before. As Nadine mentioned, I've been one of the people for the last 30 years developing more pixels and capturing more areas and better resolution and working through that, mostly in the manned aircraft, aerial imagery, and LiDAR type of area sets. And what I found about a year ago was that we're a flood of pixels. There's just so much data now, and I think it's been mentioned here before. What we really need is a capability now to take that and find those insights. So that's really what Terra Analytics is focused on, is that taking that pixel data set and understanding what the story is behind those pixels and exposing that to different types of end users or different types of end applications for that. So one of the ones I've been focused on, I have a real affinity to, is around post-disaster. A lot of the organizations I worked with, we did a lot of post-disaster collection, whether it be a wildfire in Hawaii, whether it be an earthquake in Haiti or a hurricane in Florida. I've seen a lot of these impacts of these areas. And for example, last year, we saw over $140 billion in property damage claims. It was a particularly bad hurricane year. This year has been better for them, but it's only a matter of time across that where that comes through. Right now, 93% of all claims for insurance companies are weather-related, and really is the biggest driver for them as to what their exposure is for their risk. What we wanted to know is how can we better manage that? How can we, going forward, be able to develop tools to be able to align that better for the policies for those organizations? So one of the things that I found through my research was that for every dollar spent on property mitigation, actually had the potential of returning $13 in disaster recovery savings. So that meant that if you spent $1 before a disaster, you could save $13 in claims afterwards, or up to $13 in claims afterwards. This is really the thing. We spend so much time and effort on the disaster recovery, but we don't look at the mitigation level of it. And this is really what our first application around property risk score is focused on, is what can be done to mitigate these impacts before it happens rather than worrying about the cleanup afterwards. So one of the things that we look at is, climate. We've seen a lot of the climate data today, and it is amazing data and capabilities are out there, but it's really a global level. We get global climate maps, we've seen those. We get regional hazard maps, which are great as well. But for an individual who owns a home, what does that mean to me? How does that impact the risks or what could happen to my home? One of the other studies we came across found that only 1 in 10 have any aspect, or actually less than 1 in 10 homeowners have any understanding of what climate impact and what risk that is have across their home. So we saw there's an opportunity for us to interconnect the information that's being collected across climate, regional damage, and other information data sets, and be able to localize that right down to a property, but also package that in a way that allowed us to present to the end user, to the homeowner, in a fashion that they can consume that. So we do that through a couple of things, and this is where GenAI becomes really valuable for us. The first aspect is we're multimodal. We're using data from text and photographs. We're taking GIS layers, parcel fabrics, FEMA maps, flood maps, those kind of data sets, elevation data sets, and imagery, fusing that together into our data import. And then we've developed a geo-reasoning on GenAI rather, that takes that from the impact. So it's a lot of capabilities to go through that and customize that around how would a property owner, how would an insurance underwriter look at that, or risk appraiser look at that property. And then we're building out a property score. So everybody here knows about things like a FICO score or something like that. You understand how you sit within your risk profile from that. We're looking to, and we've developed a tool set now to go through and generate a property score for every property in the United States. And also the aspect of what can be done to change your score. How can you improve it? What may have happened that's decreased your score or increased your score over the last period of time. So this comes out as a result that comes back out of the system. There's two real consumer aspects of this that are really helpful for us. The first one is we're presenting the data in a summary, so GenAI can take that data set, provide that out to a user in a fashion that they can understand. There's vegetation close to the house that includes a fire hazard, or the orientation of the front door and miscellaneous debris in the yard can cause a hurricane issue for damage. These are things that can be done to mitigate those at the homeowner's level. And it gives them that information, but also it opens up the potential for them to communicate with the model and say, what if I were to do X? What would the impact be on my homeowner area? So this really helps us understand that property score, but also how we can impact that and make those mitigation efforts, and how they can have an impact on the improvement of that as well. So I'm not going to go through all of the eye chart that's up here, but there's a lot of things that go into a risk score, and there's a lot of different kinds of perils and hazards that we look at. So wildfire was a big one, and the first model we put together was around post-fire. It was the exact same time that the the Paradise fires were going on the Palisades fires were going on in LA. So it was an interesting time to go through and apply this technology we were developing about a year ago, or over the last year against that. But what we were able to do is look at the number of fundamental pieces, and we also have a peril for fire, for wind, hurricanes, so winds, tornadoes, straight wind type of impacts, and then just general liability type of issues as well, and be able to give a score across those, and then an overall score across that as well for organizations. Right now, insurers have an issue with this. These data sets come from a number of different sources, and they're not consistent across those sources. So it's hard to get an understanding of exactly what the impact is at any given location. This normalizes all those data sets for them and gives them a consistent data set. Also something they can share. A lot of times the data they're getting isn't packaged in a way that allows them to be able to share out to the customer for that. And so what we end up with then is, for example, vulnerabilities, mitigation strategies, and moderation of that. One of the things that insurers are looking for regulatory efforts is being able to provide their risk scores with some sort of description, some sort of documentation around that, so they understand why that property was set up in that fashion, why it was maybe a weakness in the house or other types of applications. The ability to provide that rather than just your property failed because of risk score is a much more effective fashion for us to communicate to policyholders. So one of the things that we looked at to begin with was actually benchmarking this against some of the events that happened, as I mentioned, in the fires. So when we're going through the data set on the pre-fire data, this property came up as one of the ones that had a very low risk factor for wildfire. And one of the things that we looked at around that was the ability for our system to take both those aerial images, near-infrared data sets, GIS layers that you see overlaid on top of that, as well as street view data, and be able to interpret that and provide that information back to us was really telling for us. So one of the things that we discovered from this was the only house in the entire block that survived the fire, and it was the only one that had a rating that was better than average for the area that we ran against it. So it does demonstrate the fact that there is a potential for us to improve these. It's not unscathed. There was definitely some damage to the house, but it was not a total loss as the other houses were with that. So this is one of the first applications we've developed with. We're also looking at other types of ways we can help to provide this kind of complex data sets out to users, to the layperson, such that they can be able to make decisions and improve their situation. Thank you.
Thank you. All right, I hope that you have some questions in mind. Yes, and if not, start thinking about it, because at the end of the day, we're here for you. But I have a few questions to, again, whet your appetites. And to me, the diversity, like, Sean, you're trying, if I understand what you're trying to do, is like you're trying to make AI understand location in a way. You know, Jesse, you're pulling information like from everything to help somebody answer questions. Matt, you're trying to help us not do things one by one, but saying, hey, let's have a geospatial foundation model, and then on top of it, you can build your project's answer. And then, Robert, you're doing actually the application, right? You know, wildfires, risk assessment, climate impact. So the diversity is amazing, and this is what I want to emphasize. It's the sky is the limit with what we have today. So maybe I'll start with Matt, with the young guy, so on the panel. Since you're sort of the newest, I think, in terms of startup, and I started with talking about what happened since last year, and it was Google and IBM and Microsoft and AWS and Esri and Meta and like all the big guys. And you're a startup doing a geospatial foundation model. Like, how do you fit? How does this work?
Yeah, no, the things you went through at the beginning are, overwhelming, right? There's new stuff almost every week, new papers, and a lot of my former colleagues and friends at Lockheed Martin and other places, whenever they see these papers come out, they know roughly what we're doing, and I'll get a text or a call or whatever asking, does this put you out of business? Because there's, big companies spending $1 billion making these, like, how are you competing with them? And it's the inverse. It's we get to stand on the shoulders of giants that are making these extremely powerful starting point foundation models. And we had a brief discussion, I think, in Pete's talk this morning on the panel about embeddings, and that all these foundation models are the same, and that they take in data and map them to some kind of abstracted feature space. So we're basically being given the best in the world of those things, and then we can just kind of massage them for the image processing applications that we're interested in. So the beauty of it is we don't have to build these from scratch. Other people are doing that and doing it way better than we ever could. We're just sort of the creative people who can take those, which by themselves aren't that useful, these embeddings, these kind of abstract features, but then map them to things that are useful, things like, risk assessment, or all the different things we all care about in this room. You have to have that secondary mapping, and that's the tools we're building, are the things to take those embeddings and map them to different applications.
Thank you. So I ask almost the same question to Jesse, because you've been doing Dante, I think, the longest here on the stage.
It's been 2 years.
It's only 2 years?
Yeah.
All right. So it feels like way longer. Yeah. Congratulations. Because again, this is not your exploring, it's not research. It's a company that's making money, that's selling this thing to customers for safety critical applications. So when you look at the last 2 years and what you've been building, how is it getting easier, or is it getting harder, whether it's from the technology perspective or just the ecosystem?
It's definitely getting harder because people come to us as a small company, and they think that we are Google and we have the power of you can answer absolutely any question ever, and the system will give you a perfectly accurate answer in 10 seconds 100% of the time. And what we found is the same, to your point earlier about like, every time Google releases a model, oh no, like you can't do all these things, but it's actually also the opposite, where like what we're trying to do is really tell the user, like, when is that Google model the actual right thing to use in your particular workflow? And I think what's actually getting easier is that as all these things get better and better, we can focus on what we really want to be doing, which is just that in-between sort of connect the dots layer of your question today actually can be answered by grabbing this image, using the new Google, whatever, Gemini 3 model to understand some of the embeddings within that, and then use these 4 other things in this sequence to answer your question. So as those things get better and better, we're able to help people answer more and more complicated questions, where maybe they started off asking something relatively straightforward. Now they can do way more complicated things, and we don't have to build deeper in each one of those subcategories. We can just focus on our layer, which is just the connecting the dots for people.
Makes sense, makes a lot of sense. So Robert, I'll go to you because we spent a whole day, I think, here in New York for Climate Week talking about the gap between, same thing, everything I've talked about, and actually getting to a product that can be trusted. Can you summarize, seriously, like a whole day that we had, what are the gaps in terms of open data availability or support for startups or talent as you're building this company?
Well, that's a great application for ChatGPT to go and put that in, but I don't have that here right at the moment. But I think kind of one of the things I took away from that session primarily was the fact that there are a lot of people trying to solve, and climate is such a big impact across a lot of areas that it touches on everything that we do, whether it be agriculture, other pieces to that as well, that there's a lot of opportunity to reuse pieces of information that we found across that. One of the things that I think that maybe a little bit off from what your question was, but one of the things I think that we've seen is the accessibility of data to be able to build out these models or to run against these models against rather has really been a big challenge for us as a startup. In that you can do certain things with certain data from certain locations, but you can't do it with others. If you incorporate that into your solution, it potentially changes the rates you have to be able to distribute that. That's much more challenging than writing the code to be able to pull the data and run it through the navigation through the legal terms and conditions of the data uses, at least for commercial data sets. Is very daunting right at the moment. So that's one of the biggest challenges I think for anybody trying to launch a product on this right now is understanding of what you can train against, what you can do embeddings against, and what your retention capabilities are of a derived product from those.
Thank you. That's a great summary. I don't think ChatGPT would have said any of this, so that's great. So last but not least, and again, I see people lining up for the questions. So Sean, first of all, I think a group of us would love to use your application tonight to go find, great places to eat, or I love the music, right? Because you're not getting the generic search. You're saying this band is playing here, and it's to your right. But I also heard you talk about the limitations of large language models, and I think you call it context engineering. So can you talk a little bit about how we're reaching the limit? Are we reaching the limit?
Yeah, I mean, there's probably other people in this room that are deeper into this, but I think a few people have touched on it yesterday as well. But certainly, if you look at the trajectory of how long we've been working on large language models and what their capacity is and how much are we solving by being clever versus building massive data centers and throwing more compute at it. And I think Boudou's presentation was very emblematic of that, of kind of these upper bounds of where we can go. And you see, it's interesting because even in the course of the conference, a lot of what I was thinking about coming into the conference were things like world models and bringing in vision and real-world sensory input. But then also seeing a lot of the quantum presentations here today of can we break some of these bottlenecks on the compute side that are not going to be so energy intensive. But I think this is the natural trajectory of technology, right? As new innovations come out, we figure out how to harness those, adapt them, as many people have said in their own work. But we inevitably hit an upper bound of what those models are capable of, and then that inspires the next model to come along. And each one of those creates new opportunities, because some models are good at some things. LLMs are wonderful at text, and they're less good at geospatial and interacting with the real world. But conversational interfaces are incredibly helpful and a useful way to interact with technology. So each of these things brings a different ingredient to solving pragmatic problems that we have on the ground on a day-to-day basis. And so it's a really wonderful time to be an entrepreneur or just working in the space, because there are so many of these wonderful big investments that are coming along that give us opportunities to build new things and solve problems that were painful before, but give us a chance or a window to make that much more accessible and easy for the larger population.
Yeah. we live in amazing times. It's very inspiring. So I see Alan lining up. So Alan Leidner, I'm going to take this opportunity to congratulate Alan because he's all over the news this week because finally New York is committing $10 million to map the underground infrastructure of New York at the same standards of Singapore and the UK. So all because of the efforts of Alan. So definitely.
And the efforts of many, many people in city government and people all around the world who worked with us to develop the solution here. So it was a really community effort that did it, and hopefully it will yield results, give that information base under the ground that we need as much as the surface information as well. My question is, having gone through a couple of major disaster events in New York City, Hurricane Sandy and 9/11, the one thing I witnessed at the EOCs was that we wanted and needed satellite data. We didn't know which satellites to go for, and then once we started to get the data, we were completely swamped by such overwhelming amounts of data that we couldn't manage it. So a lot of that data that we needed just went to waste. And the other side of that is, one of the first things that goes down in a major disaster in a city like New York is the 911 emergency system, because it's manned by people, and the number of lines going in is immediately overwhelmed. And so you might have 100,000 people who need to communicate their status, but they can't get through. Plus the fact you want to connect people in distress with responders in the field. And there's no way of making that connection directly and quickly. So I'm just curious to know, for those two problems, what you've got in store for us, because there's a lot of help that we need to do this right.
Yeah, I can speak to the satellite imagery overload problem because we do this every day. So like US Space Force, FEMA, and a number of other organizations use us for that purpose. So to your use case, if there is a natural disaster in Chile or whatever, there's probably 100 captures or more per day across all these different commercial constellations. The NGA is dumping some stuff into global EGD and makes that available to state and local governments and others, but you don't need 300 images. You need the one that is of the exact time and place that you care about contextually. So at least our perspective and what we do for that use case is, if you ask about a fire in the Bronx or something like that, what the system will do is scan social media news, hear that that fire took place between 2 and 5 p.m. on Tuesday, and then it'll look for every other piece of contextual information. And then in the top of the search results, you'll see the 2 best satellite images of exactly at that location at that time, what news and social is saying, geolocated tweets that may have videos that someone posted from the ground, and you'll get that fast look in about 5 to 10 seconds, but then you can follow on and ask for something else. So that's how we've been doing it from a disaster perspective, and it depends on the peril. Like if it's a fire, you'll also get fire extents and other things. So it's just how do you contextualize right type of information, right time, right place, as quick as possible to remove the overload problem.
And just to quickly add on to that, you don't always have the luxury you don't know what imagery it's going to be. So you need that. That's why we're building that generalized sensor agnostic approach, because whatever imagery Dante tells us, these are the ones that has what you need in it. You better hope your model can handle those. Otherwise, you're going to have to train a new one for 6 months, and it's not useful anymore.
John, do you have one more question? All right.
Keep it quick. This is for you, Sean. Really impressive work. My head's going all over the place of where I can see the tool itself being really powerful. Imagine getting that in the hands of youth mappers. Then I can see enhancing POIs, which are notoriously tough to get, or even AI-based navigation. So, like, what's your finish line? Like, what's your ultimate objective? Because there's so many great applications of what you're doing.
That's a great question. We struggle with that on a daily basis ourselves. But yeah, I think what we want to drive towards is how do you AI enable geospatial data? We've traditionally have set data sets with set schemas that tell us very specific map facts, as Brian was saying. But the reality is the world is much more fluid, right? The poster that says there's the event for the band that Nadine wants to see tonight, the next day that changes, right? And the structure of what that looks like changes. But that's what's really exciting, right? To the point of it's not just satellite imagery that can benefit from these embeddings, that we can structure things in a way that allows us to be more fluid, both spatially and temporally across the data. So really enabling that fabric for folks to generate a variety of different use cases. So that's some of the things we've been experimenting with, because what's nice about these is it's prompt driven, right? Like literally to build that model to extract the events to say when there was a women's sale or there was a free ski movie at Patagonia or the next Warren Miller thing at the Boulder Theater, that was an hour or two of just building the prompt to extract the event, extract the time, put a temporal bound on it, and then when you ask the agent, is there an event, it does a temporal search against the event that's in the right proximity, and it gives you an answer, right? And so POI is kind of the obvious thing, and there's lots of great open data sets to test that against, but I mean, there's so many other great use cases, right? There's like humanitarian response. If you're going into an area and you want to know, has there been a damage assessment? So I have some mapillary imagery that might show me what that building looked like a year ago, and now I can take a fresh image and say, give a prompt to give me that assessment. Or I want to get the trail marker, and I want to know the name of that trail, what direction it went in, what distance it's gone, and I want to extract all that and load it in so I can do trail navigation. So I think that ability to open up the corpus of creativity for folks is what's most exciting for us. But like every startup, right, product market fit is the big challenge. So yeah, if folks have ideas, we'd love to get feedback. We map the block across the street before coming in, so if you want to see any of this stuff working kind of in real time, happy to share it.
Thank you very much. So with that, I want to thank Sean, Jesse, Matt, and Robert for, I think, being genuine, taking a risk, being willing to share what's working, where it's going, and where you need help. And thank you for inspiring. I hope you were inspired to do more research, to get more people into this community at this amazing convergence with AI, and to actually use all the resources we're being given to do good things for this world. Thank you.
Thank you, Nadine, and your panel for sharing your expertise with us today. Very interesting discussion.